Hello everyone. In this video, I am going to explain about DFSM, so called NFA. First, we'll steps involved in the conversion. Build a deterministic. First step is compute on of for each epsilon required to handle the epsilon transition. Next, we are going to compute in the start state S dash, which can be calculated by S dash equal to epsilon of S, where S is start state of the NDFSM. After that, third step will be compute active state. Active states built by developing the transition function for FSM from NFSM. Finally, decide the set of states. So all the states you have got from to K dash. Next, among the K dash, you decide the accepting states. Now, the next first step will understand how to compute epsilon closure. So epsilon closure, as I told previously, to handle the epsilon transitions that are present in the system which are not allowed, that is, epsilons are not allowed in the DF. Now let me find the epsilon closure for all the states that are present. First, I will calculate the epsilon closure of Q naught. Whenever you are finding the epsilon closure of Q, first you put the state for that we find the epsilon. Add Q here. After that, you from Q via epsilon transition can add uh, which other state from Q naught, take epsilon transition and you go to 1, take epsilon transition, you can go to Q, take epsilon transition, again you will come to naught. So you are not going to repeat the states, but not any other path is not available via epsilon transition. That's why epsilon closure of Q 1, Q and Q naught itself. So I'm writing in the order not Q, Q2. We have epsilon closure of Q1, epsilon closure of Q1 to Q2, Q2 to Q0 via epsilon and Q0 again back to Q1. That means it is same as the previous one, Q0, Q1, Q2. Similarly, we can get epsilon closure of Q, which will be Q0, Q. Finally, epsilon closure of Q3 will be Q3, as there is no epsilon transitions from it. So here we'll consider an example to build a DFSM from NDFSM. The first step is compute epsilon closure of Q for each state that are present in the NDFSM. So first we'll find epsilon closure of Q1. So from Q1, taking epsilon transition, we can get Q2, and Q2, taking a transition on epsilon, you can get Q7. No further transitions can be added. So always remember, when this state has to be added here to Q1, then from Q1 to Q2 by epsilon from Q2 to Q7. No further states can be added. From epsilon closure of Q2. So first of all, we'll add this Q2. From Q2, taking epsilon transition, maximum you can add only one state, that is Q7. So Q2 at Q7. Epsilon closure of Q6 will be from Q6, you're taking epsilon transition, only one transition path we get. So that will give you Q2. From Q2 further, taking epsilon transition, we get Q7. So the epsilon closure of Q6 will be Q2, Q6 and Q7. For the other states, there is no epsilon transition. That is why from those states. That is why it is epsilon closure of Q3 will be Q3, epsilon closure of Q4 will be Q4, and Q7 will be Q7, and Q8 will be Q8. Next step is to find the start state for the DFSM. S dash will be equal to epsilon closure of S. S is the start state of NDFSM. The start state of NDFSM is epsilon Q1. So epsilon closure of Q1 will be Q1, Q2, Q7. Once after finding the start state, next we have to build a active states. So that means you need to compute a delta dash, that is a transition function for the DFSM. Now, so here I am going to build the active states in the table format. So all the rows represents the states and all the columns represents the input symbol. Input symbol you can observe here are only A, B and C, and epsilon can't be a input symbol. Now the first active states need to be a start state of the DFSM. This is the start state of DFSM. This is the start state of DFSM. So add that. So we get Q1, Q2, Q7. How do we get the new active states here? Q1 on A doesn't make any transition. Q2 on A doesn't make any transition. Q7 on A doesn't make any transition. So it is null. Now let's check for this. So we have three states in this state. So see, remember this will be a one state in case of DFSM. So Q1, Q2, Q7, you should see where it is going to make a transition on B. Q1 on B, it is going to make a transition to itself. So that's why we need to add here epsilon of Q1. Q2 on B making a transition to Q3 and Q5. That is why epsilon of Q3 union epsilon of Q5, and then Q7 on B is making a transition to Q8. That is why epsilon of Q8. Epsilon of Q8. So this will give us the states Q1, Q2, Q3, Q5, Q7, Q8. And remember, here we should not repeat any states. Next, Q1, Q2, Q7 on C is not making a transition on Q1, Q2, Q7 is not making a transition on C. That is why it is null. Next, how to add the next state? So, see, always you go on adding the states here from these rows. First include from this, next include from this row, next include from this row, until you don't get a new state. Now first of all, null is the new state I am going to get, so add it here. So null on all input will be always null. Null on all the input will be null. Next, after adding this I finished adding. Next add this. So Q1, Q2, Q3, Q5, Q7, Q8 on A is what? Q1 on A is null. Okay, so no adding. Q2 on A is null, so no adding. Q3 on A is taking us to Q4, so epsilon of Q4 union Q3 on next is Q5. Q5 on A is taking us to Q6, so add epsilon of Q6. Then Q7 and Q8 is not making a transition on A, so leave it. So this will give us epsilon of Q4 will be Q4, Q6 will be Q2, Q6, Q7. Similarly, we can add or find the other active states on for B and C. These are the states we are going to get. Now once adding this, so with this it is done, with this it's done. So last state in the row is null, which is already present in the among the active states. No adding null again. So this row also finished. Now we'll come to Q2, Q4, Q6 that we can add. So find the new states on A, B, C input symbol. Okay, once after finding for Q2, Q4, Q7, this is also done. Next we need to add the state. Similarly, go on adding the new states from the each row until you don't get any new state. All these states I'm going to get from the previous slide. It's a continuation of that. See, here I have Q2, Q7. Finally, I'll get from this. So null is already added. Then I will get. I finished from the. I finished the new states from all from the previous slide. Now Q2, Q7. I'm going to add Q2, Q7 is going to give me these new states. These are not new states, null Q3, Q5, Q8. Once this is done, Q2, Q4, Q6, Q7 is already added. So next Q2, Q6, that is also added. Q4 is also added. Okay, all these I'm going to, these are the new states I'm going to get from the previous slide. So once only Q2, Q7, Q2, Q7 is also added. See, we are getting the states repeatedly, that is already, which are already existing. Q2, Q6, Q7, finally, the state I'm going to add. That is going to give me null Q3, Q5, Q8 and Q2, Q7, and all these states are already present in the active states. Next, once it's done, write k dash, put all the active states that is present in the active states column under k dash, and among this you decide a dash. How to decide a dash? So from the NDFSM it is clear that Q8 is the from the NDFSM it's clear that Q8 is the accepting states. So you just include those states that is having Q8. So I'm adding here this entire state I'm writing here, this state I'm writing here, and this state I'm writing here. So using these k dash, a dash and transition function, you can also build a DFSM. So this is about NDFSM to DFSM conversion.